Dear GATE aspirants, an interesting structure to understand the network subject. Shall we understand, sir? Yes. This is what the structure given is, a source and with resistive network, and questions were asked here. What are those questions? Find current through each R. Examiner's interest is to find current in each resistance. Find voltage across each R. Find power absorbed by each R. Find total power absorbed by all the resistors, and find power delivered by the source. Done, sir? Right. Let me expand this. Yes. Hope it's visible to you, dears. Fine. Examiner's interest is to find current in each R. Right. Come on, tell me, engineers, which analysis is easy here? Mesh analysis or nodal analysis? Which analysis is easy? Mesh or nodal? No mesh, no nodal. Single source problems, you have to think like this. Single source problems, we go with voltage division, current division techniques for finding current and voltages. I repeat my statement. Single source problems, we go with voltage division and current division techniques. Fine, sir. We can also understand like this. I want to find current of this branch. Current can be calculated by how many techniques? 3 techniques. Ohm's law, current division and KCL. To find current in this branch by using Ohm's law, did examiner given any voltage here? Do you know any voltage to apply Ohm's law for finding this branch current? No, sir. So finally, we can't apply Ohm's law in calculating this branch current. Can I apply KCL for finding this branch current? If you want this branch current, if this branch current and this branch current is given, if you know these 2 branch currents, this branch current can be easily calculated with the help of KCL. Yes or no? But this branch current is not given, unknown to us. Therefore, even we can't go with KCL. Only one Bhagwan in finding currents, current division. To apply current division, what are the terms and conditions we have? To apply current division, we require total current and the circuit should be parallel circuit. We require total current and the circuit should be what circuit, sir? Parallel circuit. Then only we can find current in all the branches. So, to find total current, let us find R equivalent looking from this source. Let us find R equivalent looking from this source. Come on, sir. Tell me, current comes like this, divides like this, like this. Current that comes here divides into this and this. How these 2 connected? Yes. 30 and 60, how they are connected? In parallel. In parallel, what is same, sir? Voltage is same. These 2 connected in parallel. What is the equivalent, sir? 20 ohms. What is the equivalent, sir? Here, 20 ohms. How this 20 ohm connected? In series. What is the equivalent, sir? 40 ohms. How this 40 ohm and this 40 ohm connected? In parallel. What is the equivalent, sir? 20 ohms. How this 20 ohm, 80 ohm connected? In series. What is the equivalent? R equivalent is 100 ohms. Students will have a doubt. Sir, please draw the equivalent circuit, then we will be understanding. Yes, sir. I am drawing the equivalent circuits here. What is this resistance? 20 ohm. First we have done 30 parallel 60, even that is 20 ohm. Here we have 80 ohms. Here we have 40 ohms. Yes, this source is 100 volts. Yes or no? Right. 20-20 series 40, 40-40 parallel 20, 20-80 series 100. Next, what can be the other circuit that we can draw? 40 ohms. Here, one more resistance, 40 ohms. Here, 80 ohms. Here, what is the source value, sir? 100 volts. What can the next circuit? Yes, what can be the next circuit? 20 ohms and this value 80 ohms and 100 volts. Hope it's clear to you now. What is the equivalent resistance seen by the source, DS? It is 100 ohms. 100 volts by 100 ohm. How much current comes out of the source? How much current comes out of the source, sir? 1 ampere. So 1 ampere current comes like this. This is 40, this is 40. Parallel circuit. Happily can apply current division. Yes, what is current here? Half ampere. And what is current here, sir? Half ampere. Now 40 we can split into 20, 20 in series. What is current here, sir? Half ampere. What is current here, sir? Half ampere. What is this current? 1 ampere. This 20 we got by doing the parallel combination of 30 and 60. Therefore, again current division happens, and you tell me what will be current in this branch. When half amp is coming like this, current here will be half into opposite resistance. How much? 60 by total resistance 90. This current is 1 by 3 ampere. Do similar current division. Here current is 1 by 6 amperes. Let us plot all the currents, dears. All the currents. What is current here we got? 1 ampere. What is current here we got? Half amperes. Half amperes. Next, first question is over. Find current through each R. Yes, we have currents in all the branches now. What is next question? Find voltage across each R. Voltage across each R. Yes. Current entering into resistor plus current leaving the resistor minus what is voltage across this resistor? 80 volts. Next, current entering into resistor plus leaving the resistor. What is voltage across the resistor, sir? 20 volts. 20 volts. Next, current entering the resistor plus leaving the resistor minus what is voltage here? Plus 10 volts. Current entering plus leaving minus what is voltage across resistor? Plus 10 volts. I into R, sir. Voltage we have to find. Voltage can be calculated by how many techniques? 3 techniques. Very first technique, Ohm's law. To find voltage by using Ohm's law, I require current and resistance. This blue multiplied with red resistance, black voltage, 80 volts. Done, sir. Next, current into resistance plus minus what is the voltage here, sir? 10 volts. Now I have voltage across all the resistors. Let us find power absorbed by each R. Let me use pink pen. Power absorbed by each R, power formula. We are into IR. Come on, sir. What is this? Black into blue. This 80 volts into blue current. 80 volts into 1 amp. How much? 80 watts. Come on, sir. What is this black voltage into blue current? Black into blue is pink. How much? 10 watts. Black into blue. How much? 5 watts. Black into blue. How much? 3.33 watts. Black into blue, pink, 1.667 watts. This is what power absorbed by each R. Now exam is asking, question D, find power absorbed by all the resistors. Please have a look into the question. Find power absorbed by all the resistors. Find total power absorbed by all R's. Question E, find power delivered by the source. If you want to find power absorbed by all the resistors, yes, let us add power absorbed by all the resistors. Add all the pink powers, sir. Add all pink powers. How much you are getting, sir? 80 plus 10 plus 5 plus 3.33 plus 1.667 watts. This is what power absorbed by all R's. If you calculate this, you will be getting as 100 watts. You will be getting as 100 watts. Next, let us calculate what is power delivered by the source. Let us calculate what is power delivered by the source. Voltage into current, sir. Current is 1 ampere. Come on. What is power delivered by the source, which you call as PDL by the source? Power delivered by the source is 100 into 1. How much, dears? It is simply 100 watts. Come on, engineers. Power delivered equals to power absorbed. Telegan's theorem is verified. T dot T, sir. Telegan's theorem is verified, not table tennis. Telegan's theorem is verified. Sir, answers we got, whether it is correct or not. Answers we got, they are correct or not. Yes. Sir, the beauty of network subject, you can verify your answers on your own with the help of basic laws. What are the basic laws? K laws. What is the statement? KVL, second statement. 100 equals to, started positive, go to negative following KVL sign condition. 100 equals to, come on, what is the voltage here? Plus 80, come on, plus 20, 100 equals to 100, KVL is matching. Or you take 10 equals to, started positive, go to negative, 10 equals to 10. Come on, 10 equals to, observe, 10 equals to minus 80 plus 100 minus 10, KVL is match. You take any closed part, yes, KVL will perfectly match. Next, KCL please. How much current is coming out of the source? 1 ampere. If you observe, see, 1 by 3 and 1 by 6 adds like what here? 1 by 3 and 1 by 6 adds like what? Half ampere. What is this current? Half ampere. Both currents adds like 1 ampere. Whatever the current that is coming out, same current is entering negative terminal of the supply. Next, 1 amp coming like this, divides like half and half. Again, half and half adds like 1. KCL is match, KVL is match, power law is match. Answers which we got is 100% correct. Done, sir? Right. Any resistive network, answers correct or not, simply follow this statement, very important. Any resistive network, answers correct or not, verify VIP loss. You can remember like very important problem. Any resistive network is very important problem. Verify VIP loss. Yes, I can say you are perfect with network subject. If you are perfect with this structure, I can say network subject is easy for you, sir. Network subject is easy. Done, yes? Let us go with next question. This is the very first question. Let's go with next question. Sir, what same structure I will take? Whereas in this structure, first I have calculated current. With the help of current, I calculated voltage. Whereas in the next structure, I want to calculate voltage first and current next. CDS, observe please. Same structure, but here question A is changed. Find voltage across each R first. Find current through each R. No mesh, no nodal. Voltage division, current division. To find current first, current division. To find voltage first, voltage division. Done, sir? To apply voltage division, what are the terms and conditions we have? To apply voltage division, the condition is circuit should be series circuit and we require any one voltage. Done, sir? Right. So, let us draw the subsequent networks here for applying voltage division. Why? Because to apply voltage division, circuit should be series circuit. Here this is not a simple series circuit. Let us redact that network and draw the single equivalent series structure. Come on, sir. As like earlier, drawing here, this is 20 ohm, 30, 60 connected in parallel. Again, this is one more 20 ohm. Here, you will be having a 40 ohm resistor. Here, it is a simple 80 ohm resistor given by the examiner. And here, this is a 100 volt source. Drawing one more network. 40 ohms, 40 ohms, 40 ohm, 40 ohm. This is 100 volts and this is 80 ohms. 80 ohms. What can the next structure, sir? Next structure, yes. Please have some patience in drawing all these structures, understanding this, dears. Once you understand this, you can play the subject like anything, okay? Right. Next, observe carefully, please. Voltage division to apply, what the conditions has to be satisfied? It should be a series circuit and any one voltage should be known. Yes, applying voltage division, sir. Plus, minus, why plus minus, sir? Current comes like this. 100 into respective resistance, 80 by total resistance, 100. Finally, what is this voltage, sir? 80 volts. 80 volts. Now, I want to find voltage across this. Two ways you can find voltage across this. Why? In what ways you can find? One way is by voltage division. You can find this voltage either by voltage division or you can apply by KVL. To apply KVL, what are the terms and conditions? What are the terms and conditions? KVL is applicable for a closed path. In a closed path, if n minus 1 element voltage are known, nth element voltage can be easily calculated with the help of KVL. Here we have 3 elements. Here we have 3 elements, and if you know 2 element voltages, third element voltage can be easily find. Arbitrarily put 2 polarities, sir. Okay, kept. Started positive, go to negative. If you come like this, minus 80 volts plus 100. What is this voltage, sir? 20 volts. This voltage I got by KVL. You can also calculate by voltage division. You can also calculate by voltage division. Done, sir? Next, let us find other branch voltages. Yes, please. What is this voltage we got? 80 volts. Can I apply KVL to find this voltage? Yes, this is a closed path in which you have only 3 elements. I know 2 element voltages. Third element voltage can be easily calculated with the help of KVL. Arbitrarily put 2 polarities, sir, plus and minus. Started positive, go to negative following KVL sign condition. What is this voltage, sir? Minus 80 plus 100. This voltage is 20 volts. Sir, I want to put reverse polarity, sir. Put by, yeah, no problem. If you put plus here, minus here, what you get? Minus 100 plus 80, you are getting negative voltage. That's it. Once you get negative voltage, reverse the polarities to get the positive voltage. Done, sir? Fine? Getting a point? Following? Done, yes. Happy. Next, I want to find this voltage, this branch voltage. Started positive, go to negative. Yes, what is voltage, sir? Plus 20 volts. Plus 20 volts. Done, sir? Next, let us find this voltages, sir. Plus minus 80 volts. Plus minus 80 volts. Across 40 ohm, you have 20 volts. Sir, I am putting here. Plus minus 20 volts. Hope this black is visible to you. 20 volts. Whereas this 40 ohm is a series combination of 20 ohms and 20 ohms. 20 ohms and 20 ohms. Apply voltage division, sir. You will be getting plus minus 10 volts plus minus 10 volts. Sir, how you got this voltage? Please explain. Okay, dear. I am here. Shyam sir is there. Let us take these 2 resistors. Yes. Come on, tell me. What I am doing is, this 20 volts 40 ohm, I am representing like this. What is the source value, sir? 20 volts. This 40 ohm, can I replace with 20 ohm, 20 ohm? Yes, series combination gives the same 40 ohm resistance. 20 volts, apply voltage division. What happens here, sir? Plus minus 10 volts, plus minus 10 volts. The same 10 volts I have kept here. Clear, sir? Right? Yes. Next, let me go with the voltage, or let me go with the given circuit and write voltage across each resistor. Sir, whatever the voltages I got from this circuit, the same voltage I am marking in the original circuit or given circuit. Plus minus, what is this voltage, sir? 80 volts. Next, plus minus, this voltage we got as 10 volts. Plus minus, what is this voltage, sir? 10 volts. Observe carefully. Here, this 20 ohm is an equivalent of, 30-60 connecting in parallel. Therefore, apply KVL to get voltages. Plus minus, what is voltage, sir? Minus 10 plus 80 plus 100, you will get as 10 volts. Plus minus 10 volts. Sir, many will be having one doubt. What is the doubt? Let me explain here itself. Yes, let me explain here itself. This 20 is an equivalent of 40-40 in parallel. Yes or no? Yes. Across 20 ohms, what is the voltage we have? 20 volts. Even across 40 and 40 also, we get the same 20 volts by KVL. Having any doubt, let me explain like this. Across 20 ohm resistor, we have 20 volts. Now, how we got this 20? By doing a parallel combination of 40 and 40. Yes or no? Right. 40 ohms and 40 ohms. Now, if I ask you, what is voltage across this? How much, sir? The same 20 volts. If I ask what is voltage across this, started positive, going how much? 20 volts. Here, what is the voltage? 20 volts. Is it clear, sir? Is it clear? So, finally, what is the conclusion? Across a resistor, if you know the voltage, and when that resistor is replaced with a combination, across the same combination also will be having the same voltage. Why? Because they are connected in parallel. In parallel, voltage is same. That is what I am saying. Done, sir. Right. So let us go to the given circuit and write all the voltages. Yes, voltages are written here, dear. Hope the screen is stable. Hope the circuit is visible to you. What is the next question? Find current through each R. Current can be calculated by how many techniques? 3 techniques. Ohm's law, current division, KCL. To apply Ohm's law, what data is required? You require voltage and resistance. V by R gives you the voltage. 80 by 80 gives you the current of 1 ampere. Next, that current in upward direction or downward direction. If you write this current in the downward direction, this resistor has to deliver power as per sign convention of power. Can resistor deliver power or absorb power? Absorb power. So now one statement, current always enters at positive terminal for a resistor. Current always enters at positive terminal for a resistor. Done? Right. Next, here sir, 20 by 40, how much current flows? V by R, half amperes. Next, 10 by 20, how much current flows? Half amperes. Next, 10 by 30, how much current flows? 1 by 3 amperes. 10 by 60, how much current flows? 1 by 6 amperes. Now I have current in all the branches. You can find power absorbed by each R. You can find total power absorbed by all R's. You can also find power delivered by the source. Telegrams theorem is perfectly verified here. Done, dears? Is it clear for you? Right. Let us go with next question. What came the next question? Let us replace this voltage source with current source. Let us replace this voltage source with current source. Erasing, sir, replacing voltage source with current source of value 1 ampere, calling this as question 3. Question 3. Done? Right. What is the similarity between first question and third question? I hope I have not given any numberings here. Sir, this is question 1. This is question 2. Now we are in question 3. Yes. What is the difference between first question and third question? Structure is same. Questions are same. Source is different. Source is different. Okay. Right. There we have voltage source. Here we have current source. In first question, we have calculated R equivalent in finding current. Whereas in the third question, this current is given directly. Done, sir? Right. So how you analyze this? 1 amp comes like this. This is 40. This is 40. What is current here? Half ampere. What is current here? Half amperes. Half amp coming like this. Current division will take place. 1 by 3 and 1 by 6. Adds like what? Half amp. Half adds like what? 1 amp. Current through each R. Yes, we know this is known to us now. Voltage across each R. By Ohm's law you can calculate. Power absorbed by each R. Just I square into R or VR into IR you can calculate. Total power absorbed by all R's easily you can calculate. Can you calculate power delivered by the source? Can you calculate power delivered by the source? Not possible, sir. Why not possible? Why? Because we don't know what is voltage across current source. I told you in KVL sign convention itself clearly. In every voltage source you will be having current. Similarly, across every current source you will be having what? Voltage. Let us arbitrarily put two polarities in calculating voltage across the current source. I told you clearly, voltage across current source we can calculate only by using KVL, sir. No other law is there to calculate voltage across current source. Only by using KCL we can calculate. Only by using KVL we can calculate voltage across the current source. Done, sir? Yes. What is the statement? Beautiful statement. Golden statement. Second statement of KVL. Started positive. Go to negative following KVL sign convention. What is voltage across this? Some 80 volts. What is voltage across this? Some 20 volts. Started positive. 80 plus 20. Vx value is 100 volts. Vx value is 100 volts. So this is what the third question. Now easily you can write power delivered by current source Vx into 1, how much dear? 100 watts. 100 watts. Shall we go with next question? Fourth question. What came the fourth question? You can easily guess what is the fourth question. Replace voltage source of second question with current source. Observe, sir. Second question. What is the source we are having? What is the source we are having? Voltage source. Replace this with what? Replace this with what? Current source. Yes, I am replacing with current source. What is the similarity between second question and fourth question? Structure is same, source is different. Questions are same. Questions are same. Find voltage across each R. Come on, sir. How you find voltage across each R first? Many will be still thinking, sir, current comes here, voltage is 80. I am asking to find voltage first. Whereas you are saying with the help of current you are calculating voltage. Whereas here I want to find current with the help of voltage. I repeat my statement. Many will say here, sir, 1 amp coming like this, 1 amp goes like this, 1 into 80 is 80. Then what is the difference between third question and fourth question? Even in third question we have done the same, right? 1 amp is coming like this, 1 into 80, 80. This is what we have written. What is the difference between third question, second question and fourth question, or third question and fourth question? Here you have to find voltage first. How we can find voltage first? That's why DS, I am clearly telling. Single source problem. To apply voltage division, any one voltage should be known first. Can I draw the circuit equivalent as simply like this? Total 100 ohm resistance with a 1 amp current. Yes. You tell me, sir. What is the current here? 1 amp. What is voltage across this? 100 volts. Once you know this voltage is 100 volts, what is voltage across current source? 100 volts. Now we clearly know voltage across this current source as 100 volts. Once you know voltage across current source as 100 volts, easily you can apply voltage division as similar to second problem, and you can find voltage across each R. I repeat my statement. Finding R equivalent, which is 100 ohms. 1 amp current flowing like this. What is this voltage, sir? 100 volts. Once this voltage is 100 volts, by KVL, arbitrarily two polarities, started positive, go to negative, this voltage is 100 volts. The same 100 volts I am putting across the current source. Now you apply voltage division, you will be getting voltage across all the branches. Sir, no. This is what the fourth question is. Clear? Right. So, 4 questions discussed. If you feel I have discussed only 4 questions, it's wrong, sir. Let me go to first question. Let me go to first question. Yes. So, this is what the structure we have discussed. Fine? Right. How many questions we have discussed? Observe carefully, please. Earlier we have analyzed by putting source here. We can put this source here. Remove source from here, or you can put some source here. Or remove source here, you can put source here. Or remove source here, you can put source here. Or remove here, you can put source here. Yes or no? Right? Yes. How many structures we have analyzed? We have analyzed 4 structures. 4 structures. Next, at how many branches we can put the source, sir? How many positions we can put the source? Observe please and you tell me, sir. Yes. 1, 2, 3, 4, 5 positions we can put the source. Okay, let me write this number here. 4 into 5 into 5. Yes, position of source. Yes or no? Next, how many questions we have discussed? How many questions we have discussed? 5 questions. A, B, C, D, E. 5 questions we have discussed. 5 questions we have discussed. Yes or no? Right. Next into, Suno please. What is question A? Find current through each R. Yes or no? Means every branch resistance can be a question. Yes or no? Sub-objective question, sir. If I ask like, this current can be one objective question, 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 this current can be one objective question. In every question we have sub-objective questions. Yes or no? Yes. So I am writing into 5. What is this, sir? Sub-objective questions into, yes. For all the time we have analyzed source with this polarities, we can also reverse the polarities and we can also start analyzing in this direction. Simply I want to put into 2. Come on engineers, you tell me how many objective questions completed. 4 5s, 20, 20 5s, 100, 100 5s, 500, 500 2s, 1000. I can say 1000 objective questions completed in this session. How many objectives completed? 1000 objective questions completed in this session. Sir, at least what I am saying is, this structure has a scope of 1000 objective questions. This structure has a scope of 1000 objective questions. Students used to ask me in offline classes, sir, give some practice questions and all. Yes, what I say, follow the structure, put source at some other position and do the problem. No need to come to me, sir. Verify your answers by using VIP laws. Any research network, verify VIP laws easily. You will be getting the concept. Clear, sir? Still some students will be asking, sir, I am the topper of the college. Give some homework to me. Give some homework to me. What I used to say is, remove this branch, do the problem, answers correct or not, faculty help not required. You can verify your answers by using VIP laws. Or let me do like this. Remove this resistor, do the problem, correct or not, faculty help not required. You can verify your answers by using VIP laws. Some will say, sir, I am an above average student. Give this structure, give some homework to me. Remove this resistance, do the problem, analyze structure, answers correct or not, my help not required. You can verify your answers by using VIP laws. Sir, I am an average student, please give some structure for understanding the subject. Short circuit this branch. Short circuit this branch, yes, this branch has gone. Analyze circuit, yes, verify your answers by using VIP laws. Okay, right. So, with this, sir, once this branch has gone, left over only with 80 and 20 ohms here, which are in series. Started with a very basic structure in Ohm's law like this, and we have concluded with best structure in understanding subject. Sir, I am not saying this is the toughest structure, but I am saying this as the best structure in understanding the subject. Why? Because we used Ohm's law for finding branch current, we used Ohm's law for finding branch voltage, Ohm's law is over. We used voltage division, we used current division, we used KVL, we used KCL. Whatever the basic techniques we have learned till date, all the basic techniques I have applied in this problem. So, obviously this is the best structure in understanding the subject. Come on, sir. Right. Students used to ask me, sir, let us put source at some point and do the problem. Sir, since this is online class, we can go with infinite service. If it is offline class, obviously we will be having lot of limitations. We have to close subject in 50-55 hours. Managements won't allow to teach for more than 5 to 10 hours extra. Whereas in online, it's our organization. I am the director here. I can go with infinite service TS. Done? Right. Let me erase this source. Yes, let me erase this source. Let us put source here and understand the subject. Students, out of interest, they want to put source at some point and they want to analyze the subject. Here I want to give some tips for you in analyzing the subject. Yes, right. First you tell me, sir, current comes like this, current divides between this and this. Immediately students will say, as current has divided, they want to say 20 is parallel with 60. It's a blunder. First point, please learn this. It's a blunder. Why it's a blunder? Current entering means plus, leaving means minus, entering means plus, leaving means minus, positive connected here, this negative connected here, this negative connected here. Come on, sir, tell me. This point, both the points same or different? They are different. Why? We have element between these 2 points. Correct or not? Yes. So, first 20 parallel 60 is a blunder. Come on, sir, let us proceed further. Let us call this current as some I. Let us call this current as some I1. Let us call this current as some I2. Right? I1 current comes like this. Let us say the current has divided like some I3 and I4. I3 entering means plus, leaving means minus. I4 entering means plus, leaving means minus. Positive connected to this point. This negative connected here. This negative connected here. Between these 2 points, I am showing, please observe. Between this point and this point, this 40 and 80 are connected in parallel. 40 parallel 80 is perfectly correct. Students want to solve like this. They will get some fractions. They will get some fractions, and when verifying with the power loss and all, they used to get some doubts. And they will ask me, sir, whether my answer is correct or not, or loss are not getting matched. DS. Here our intention not to do any PhD with the fractions. We all hate fractions or not? Huh? And understand the subject at least. We all hate the fractions. Yes or no? Right. So here, see how I have explained. Look into my structure, or how I have explained. I have taken values in such a way that they are easily reductible without any fractions. 30 parallel 60, 20, 20 20 series 40, 40 40 parallel 20, 20 80 series 100. Whereas here, let us take the similar values in understanding subject first. Again, don't ask me the doubt, sir. If examiner gives values, obviously you have to go with the values given by the examiner, sir. You can't change the question paper on your own, right? Yes. So what I am saying is, let us understand subject first. Let us take here some 30 ohm and 60 ohms. Let us remind this as some 20 ohm as it is. 30 parallel 60, yes, equivalent is 20. 20 20 series, equivalent is 40. Let us take some 40 ohm here. Let us take some 80 ohm here. Now you analyze, sir. Change the values when you put the source at this point. Change the values like this. Understand? Without the help of calculator, you will understand the subject. Whereas if you want to proceed with the red values itself, proceed, you will get some fractions, take the help of calculator, then understand the subject in half an hour, it takes some 1 hour. My intention to make the subject that easy for you. Done, sir? Right. So here, even we can quote some best example. Student with the name Stanley, 2014, 41st gate ranker. He got placed with IOCL, and after 1 year, again he came to Hyderabad to meet me. He said, when meeting me, he said, one statement, sir, started positive, got negative, it's good morning. Okay, follow the KVL second statement, sir. You will enjoy the subject like anything else. Fine? Right. And even he has cracked with local government jobs, and he is working as SPDCL at high-tech city. He is happy with his job now. Done, sir. Let us take black values over now. Yes, please. Let me draw some circuit here, please. Between these 2 points, 30 is connected in parallel with 60. Let me compress this. 30 is connected in parallel with 60. Drawing, please. 20 ohms. Parallel with 60. Simply I am putting here 20 ohms. See, between this point and this point, we have that resistance. Yes, over. Problem is over. 80 ohms and 40 ohms. Come on, sir. Now you tell me how you analyze this. How you analyze this? 40, 40 in parallel. Okay, right. 20, 28 series, 100. 1 amp comes like this, divides like what? Half ampere and half ampere. Whatever the half amp that is coming, this 20 is an equivalent of 30 parallel 60, na? This half amp divided between 30 and 60. So let me write the values in the given question with the help of a pink pen. Right. Sir, red structure with the black resistance values with the pink answers. Okay. For better clarity purpose, I am using the word colors. Done, sir? What will be this current here? 1 ampere. What is this current, sir? Half ampere. What is this current? Half ampere. What is this current? 1/3. What is this current? 1/6. Next, with the help of green pen, I am writing the voltages to verify K loss. 1/3. See, pink current into black voltage is pink current into black resistance is green voltage. How much? 10 volts. Okay, right. 1/6 into 60. What is this voltage value, please? 10 volts. Here, sir, pink current half. Let me expand this. Hope it's visible to you now. Yes, pink current half into 20 ohms. How much? 10 volts. Half into 40 ohm. How much? 20 volts. Simply, so now please, 1/3 amps coming like this. 1/6 amps coming like this. This is half. Half and half adds like what? 1 amp. What is this voltage, sir? 80 volts. Shall we verify KVL? Sir, do this problem for 2 times. You will write much faster than me. Clear here? Come on. Right? Yes, 100 equals to, apply KVL, 100 equals to. What is voltage here, sir? 10 here plus 10, 20. Here 80. KVL satisfied. Done? Right. This is what a basic structure in understanding network subject. Like I used to call this as a 1000 problem structure. Come on, sir. Finally, how many objective questions we have solved? 1000 objective questions. Clear? This is how it is. This is how the approach of Veda Gate Academy faculties will be. Here, all the faculties and the directors, they will teach with a lot of energies and passions to make subject interesting and easy for UDS. We are here to make you rankers. Thank you. All the best.